Friends, today I shall discuss on beta function. First of all, we shall see the properties of the beta function. Then in the next video, we shall learn the application of beta function. It's an important topic for entrance examination. If you are new here, please subscribe the channel and press the bell icon for the future updates. Friends, what is beta function? The beta function, also called Euler integral of the first kind, is denoted by beta mn and it is defined by the definite integral as beta mn is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x whole to the power n minus 1 dx, where m and n both are greater than 0, that is positive. Now friends, what are the properties of beta function? The properties of beta function are respectively beta mn is equal to beta of nm. This is the property of symmetry. That means the symmetry also holds in beta function. Number 2, beta of mn is equal to integration 0 to infinity x to the power n minus 1 upon 1 plus x whole power m plus n dx is equal to integration 0 to infinity x power m minus 1 upon 1 plus x whole power m plus n dx. And the third property, this is also another important property, beta of mn is equal to twice integral 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. Now first of all, we shall learn beta of mn is equal to beta nm. So friends, by definition we can write beta of mn is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x whole power n minus 1 dx. We know that, friends, integral 0 to a fx dx is equal to integration 0 to a f of a minus x dx. This is a property of integration, definite integral. And using this one, we can write that beta of mn is equal to integration 0 to 1. This x can be written now 1 minus x whole power m minus 1 into 1 minus this x also be written like this a minus x, that means 1 minus x. So 1 minus x whole power n minus 1. So friends, we can now write integration 0 to 1 minus x whole power m minus 1, and this 1 is cancelled, writing only x to the power n minus 1 dx. Okay, so friends, first of all, you see that what is written in the definition, beta of mn is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x whole power n minus 1 dx. So friends, if the integral is like this, integration 0 to 1 x to the power n minus 1 x to the power m minus 1, now it is x to the power n minus 1 into 1 minus x whole power m minus 1 dx, then obviously it will be beta of nm, isn't it? So friends, beta of mn is equal to beta of nm. This is the symmetry of beta function. Next we shall see the second property. Second property is beta of mn is equal to integration 0 to infinity x to the power n minus 1 upon 1 plus x whole power m plus n dx equal to integration 0 to infinity x to the power m minus 1 upon 1 plus x whole power m plus n dx. Friends, let us consider that x is equal to 1 upon 1 plus y. Okay, so we can write from here 1 plus y is equal to 1 upon x. Now friends, from here dx is equal to minus 1 upon 1 plus y whole square dy. Now we have to change actually the limit, and we know that when x tends to 0, then obviously y is tending to infinity. You just put x is equal to 0, then obviously y will be tending to infinity. Now when x is tending to 1, then y is tending to 0, x is tending to 1, y is tending to 0, because 1 minus 1 is equal to 0. Now friends, actually we shall put the conditions, these x is equal to 1 upon 1 plus y, or these limits, in the definition of beta function. So what is the definition of beta function? By the definition we get beta of mn is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x whole upon n minus 1 dx. So here the limits, lower limit is 0, upper limit is 1. So we have actually changed with respect to y tending to infinity, here y is tending to 0, for x is tending to 1. Now friends, we write this expression now. Beta of mn is equal to integration 0 to 1. Now it is just changed infinity to 0. So this is infinity to 0, and this is x. What is x? X is equal to 1 upon 1 plus y. So 1 upon 1 plus y whole to the power m minus 1 into 1 minus x, and x is equal to 1 upon 1 plus y. So 1 minus 1 upon 1 plus y whole power n minus 1, and dx is equal to minus 1 upon 1 plus y whole square dy. So we have to replace this one also, minus dy upon 1 plus y whole square. So friends, this minus is now here, integration infinity to 0, and 1 upon 1 plus y whole power m minus 1. We have to make a LCM here, 1 plus y, and the numerator will be 1 plus y minus 1. So only y in the numerator, so y upon 1 plus y whole to the power n minus 1 dy upon 1 plus y whole square. So this is minus of integration infinity to 0. So we just change the limits 0 to infinity. Okay, we know this one, in 0 to infinity and y to the power n minus 1. So we can write now y to the power n minus 1 upon 1 plus y whole to the power m minus 1, here 1 plus y whole to the power n minus 1, and here 1 plus y whole square. Ultimately it will be 1 plus y whole to the power m plus n dy. Okay, now friends, we know another property of integration, definite integral, that integration 0 to b of fx dx is equal to integration 0 to b f of y dy. Okay, so we can use this property, and then it will be converted to beta of mn. Now is converted, integration 0 to infinity x to the power n minus 1 upon 1 plus x whole power m plus n dx. So friends, we know that beta of mn is equal to beta of nm, using the symmetry, property of symmetry. So we can write it as also integration 0 to infinity x to the power m minus 1. It was x to the power n minus 1. Now we are writing x to the power m minus 1. For this basic property, this is the property of symmetry of beta function, upon 1 plus x whole power m plus n dx. So the proof, beta of mn is equal to integration 0 to infinity x to the power n minus 1 upon 1 plus x whole to the power m plus n dx is equal to x to the power m minus 1 upon 1 plus x whole to the power m plus n dx. Finally, we shall see the third property. Property is beta of mn is equal to twice integration 0 to pi by 2 sine to the power 2m minus 1 theta into cos raised to the power 2n minus 1 theta d theta. Friends, we know that the beta of mn is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x whole power n minus 1 dx. Friends, we consider that, let us consider that x is equal to sine square theta. Okay, x is equal to sine square theta. Obviously, what is dx? Dx is equal to 2 sine theta cos theta d theta. Okay. Now we have to change the limit. When x tends to 0, then theta is tending to 0 because x is equal to sine square theta. Sine 0 is equal to 0. And when x is tending to 1, upper limit is 1, then theta is tending to pi upon 2. Okay. So what is beta of mn? Beta of mn is equal to integration 0 to 1. Now the limit will be 0 to pi by 2. 0 to pi by 2. X to the power m minus 1. What is x? X is equal to sine square theta. So this is sine square theta whole power m minus 1 into 1 minus x, 1 minus sine square theta whole power n minus 1 dx. What is dx? Dx is equal to 2 sine theta cos theta d theta. Okay. So friends, we can now write twice integral 0 to pi upon 2 sine to the power 2m minus 2 theta, and here sine to the power 1 theta sine theta, only sine theta. So we can write now sine to the power 2m minus 2 plus 1. So this is sine power 2m minus 1 theta. Similarly, cos power 2n minus 1 theta d theta. Okay. So friends, this is actually the proof. Beta of mn is equal to 2 times integral 0 to pi by 2 sine power 2m minus 1 theta into cos raised to the power twice n minus 1 theta d theta. Thank you. Have a nice day.